Hello, very good morning. Today our class is classify the two types of internet protocol addressing IPv version 4 and IPv version 6 and state the need for IPv version 6 and describe internet protocol version 6 addressing. This is our topic today. Classify the two types of internet protocol addressing IPv version 4, IPv version 6 and state the need for IPv6 and describe the internet protocol version 6 IPv6 addressing. So today in this class we are going to see all about this. So first we will see the IPv internet protocol version 4 IPv4. Internet protocol version 4 is the fourth version of the internet protocol. It is one of the core protocols of standards based internetworking methods in the internet and other packet switching networks. IPv4 was the first version deployed for production on SATnet in the year 1982 and on the ARPANET in the January 1983. Internet protocol is one of the major protocols in the TCP/IP protocol suite. This IPv protocol works at the network layer of the OSI Open Systems Interconnect model and the internet layer of the TCP/IP model. Thus, this protocol has the responsibility of identifying hosts based upon their logical addresses and route to data among them over the underlying network. So this IPv version helps in finding the addresses and also routing the data among the network. The Internet Protocol version 4 is the fourth version in the development of Internet Protocol and the first version of the protocol to be widely deployed. So this IPv version still used today in some maximum computer networks. It is very popular, became very popular and widely deployed throughout the world in the networking field. IP provides a mechanism to uniquely identify hosts by an IP addressing scheme. This is the main basic idea behind IP Internet Protocol. It is mechanism uniquely identify hosts by an IP addressing scheme. IP uses the best effort delivery, that is, it does not guarantee that packets would be delivered to the destined host, but it will do its best to reach the destination. Internet Protocol version 4 uses 32-bit logical address. So, for understanding IPv version 4 addressing is that IPv4 addresses are 32-bit numbers and are typically displayed as in dotted decimal notation. The representation of these 32 numbers in the IPv version 4 address are called dotted decimal notation. A 32-bit address contains two primary parts, the network prefix and the host number. All hosts within a single network share the same network address. Each host also has an address that uniquely identifies it. It means in any networking, or if any system is or any device is connected in the network, that is called host. That host or any device connected in the network must have an identity. That identification is called IP address. In this IP address, IPv version 4 addressing scheme, we use 32-bit numbers to identify any host in this IPv version 4 addressing scheme. Depending on the scope of the network and the type of the device, the address is either globally or locally unique. IP addresses are assigned by a central numbering authority called Internet Assigned Numbers Authority, IANA. IANA ensures that addresses are globally unique where needed and as a large address space reserved for use by devices not visible outside their own networks. So as we require that any device either globally or locally that must be identified with a number, that numbering scheme is in this situation IPv version 4 addressing, that is any device is used to identify by using 32-bit number addressing scheme. So this is the one of the example for IPv version addressing. This is dotted decimal notation. This is total 32 bits. So 192.168.10.10. So this is hexadecimal notation, this one. If we convert this 192.168.10.10 convert to binary number, that will become 32-bit numbering system. So this is one of the example in IPv version addressing. So this is called octet. The first three numbers called octet, here octet, and this is another octet, and this is another octet. So this is a scheme or structure of IP addressing scheme. So IPv version 4 contains 32-bit IP address, and this we have 4 octets, each one is having 8 bits. So 4 into 8, 32 bits are there. So in the first octet, so if you take the example like this 192.168.1.5, so this can be represented binary as a binary number. Is equivalent to 192 is equal to 11000 like this, and equivalent 168 number is this binary number, and equivalent 1 is this binary number, and equivalent 5 this is the binary number. If we represent as this is represented in 32-bit numbering system, and we are dividing these numbers into 8 bits each of 4 octets, and if we convert into decimal number by using their values, representation of values, binary representing values here, as these are 8 bits, these are the values for each and every binary representation number if we convert into decimal. So this number 1 represents 1, and 2 2 and 4, 8, 16, 32, 64 and 28. This numbering system and values are used for all the octets here. So if you are taking the binary value, binary bit value as 128 for this and 64 for this, and remaining are all zeros. So 128 plus 16 is 64 is equal to 192 we are getting here, and here 1 represent 128, and here 1 represent 32, and 1 represent 8, and remaining all are zeros. So if we add 128 plus 32 plus 8 is equal to 168, and here in this case only single one is there and remaining are all zeros, so that's why we are taking only one value as this value, and here two numbers are there, no ones are there in 4 value, and we are taking 4 here and we are taking 1 here, get together 5 we are getting, and we are forming the decimal number dotted decimal address is equivalent to 192.168.1.5. So this is a structure of IPv version 4 addressing scheme, which contains 32-bit IP address contains of 4 octets, and these are called octets. Octet 1, octet 1, octet 2, octet 3, and octet 4. So if we see the IPv version packet structure, Internet Protocol being a layer 3 protocol in OSI and takes data segments from layer 4, that is nothing but transport, and it divides it into packets. It means while sending the data over the internet, this IPv version 4 generally divides this data into packets, nothing but small chunks of data, and that each and every packet must contain IP Internet Protocol header and also layer 4 data. That is nothing but IP encapsulation. The IP packet encapsulates data unit received from above layer and add it to its own header information. So this is encapsulated data is referred to as an IP payload. The data is encapsulated, that is called data payload. IP header contains all the necessary information to deliver the packet at the other end. It means it contains source address like this, destination address, and if any options are there, header checksum, and total length of the data and identification, everything will be there in this packet. And this is the entire thing is which is in encapsulated form is called IP Internet Protocol payload. If you see details about all this version and everything, here IP header includes many relevant information number which is in this context for version number Internet Protocol IPv version 4. This is nothing but here we can see version 4, and DSCP, differentiated sources code point. This is type of service. Here we can see DSCP, differentiated service code point. It is a type of service. And ECN, explicit congestion notification. It carries information about the congestion seen in the route. So ECN, this is if any congestion in the route, this will be informed. So total length of entire IP packet including IP header and IP payload. Here we can say the total length. And identification, if IP packet is fragmented during the transmission, all the fragments contain same identification number to identify original IP packet they belong to. This one is the identification, this one. And flags as required by the network resources. If IP packet is too large to handle these flags itself, if they can be fragmented or not, in this 3-bit flag, the MSB is always set to 0. This is fragmented. And fragment offset, this is offset till exact position of the original IP packet. This is fragment offset. And time to live, to avoid looping in the network, every packet is sent with some TTL value set which tells the network how many routers, nothing but hops, this packet can cross. At each hop, its value is decremented by 1, and when the value reaches 0, then the packet is discarded. This is nothing but time to live information here. And next one, the protocol tells the network layer at the destination host to which protocol that this packet belongs to. That is the next level protocol. For example, the protocol number of ICMP is 1 and TCP is 6 and UDP, user direct protocol, is 17. So next one, header checksum. Here we can see the header checksum. This field is used to keep checksum value of entire header, which is then used to check if the packet is received error free. And next one, source address. This one, here we can see source and destination address. And source address, 32 bits address of the sender of source of the packet, and destination address, 32 bit address of the receiver or destination of the packet. And options in this, we can also see the last one, options. Here option, this is optional field which is used if the value of IHL is greater than 5. These options may contain values for options such as security, record route, timestamp, and etc. So if you see the packet structure, this all the information will be there in the packet of IPv version. So IPv version have address classes, different address classes which are used for different types of networks. Because there are a number of types of networks available, and based on the network size and everything, this IP addresses defines 5 classes of IPv version 4 addresses. This is purely based on the size of the network, and these classes are defined like class A, class B, class C, class D, and class E. Each class has a range of valid IP version 4 addresses. The value of the first octet determines the class. So all classes A, B, C, D, E are 32-bit addresses only. And in these 32-bit addresses, the first octet determines the class. It means by seeing the first octet, we can recognize which class of the IP address is. The address class divide the address space into addresses that support like large numbers of nodes. If in our network there are large number of nodes, that's this it's a large organization. We generally use class A addresses. And where we are using establishing medium number of nodes in a network, then we refer class B addresses. And if there are small number of nodes in our network and intended for a small organization, we use class C addresses. And class D used for multicasting purpose, and class E is reserved and for that is used for to be used for research and development purpose. So separate IPv4 classes are used for different types of networks. Some are used for public internet accessible IPs and subnets, that is those networks behind a router as in class A, class B and C. And as well, some classes are reserved by the Internet Engineering Task Force and the Internet Assigned Numbers Authority for specific purposes. These special ranges are used for multicasting of identical data to all computers on the network or subnet or for research, that is nothing but as in classes D and E. So any IPv version address classes contains two parts. First one is network part and second one is host part. So network identification and also host identification. So each and every class IP address version generally contains 32-bit addressing. Among this 32-bit addressing, we must have a network identification and also host identification. So the class of IPv4 address is to determine the bits used for network ID and also host ID and the number of total networks and hosts possible in that particular class. So by seeing the host ID and also network ID, we can say how many networks are available and how many hosts are possible in that particular network class. So here these are the classes, class A, B, C, D and E, and there are 4 bytes, nothing but 32 bits are there. So in the class A, the byte 1 is used for identifying the network, and remaining byte 2, 3 and 4, nothing but 24 bits are used to identify the host in that particular network. Whereas in class B, first 2 bytes, byte 1 and byte 2, nothing but 16 bits are used to identify network, and remaining byte 3 and 4, nothing but remaining 16 bits are used to identify host in the class B addressing scheme. And whereas in class C addressing, first 3 bytes, byte 1, byte 2, byte 3, nothing but 24 bits are used to identify the network ID, network, and remaining only 8 bits, nothing but byte 4 is used to identify host in the class C. And class D is used for multicast addressing, and class E is reserved for research and development purpose. So these are the details about all the classes A, B, C, D, E in a glance. If we see what are the details about class A, class B, class C, class D and class E. So now we will see the class A details. IP address belonging to class A are assigned to the networks that can contain large number of hosts. If in our network there are if we are going to establish or connect large number of hosts, large number of nodes in the network, then generally we use class A addressing scheme. So in this, the network ID is 8 bits long and host ID is 24 bits long. Always the first bit of the first octet is always set to 0 like this. Thus the first octet ranges from 1 to 127, that is nothing but 1 to 127, because this 0 indicates that it is a class A addressing. So here we have only 7 bits, here we have 7 bits. So minimum number in 7 bits is nothing but 1, and maximum number in the 7 bits is equal to 127. The higher order bit of the first octet is always A is always set to 0. The remaining 7 bits in the first octet are used to determine the network ID. The 24 bits of the host ID are used to determine the host in any network. The default subnet mask for the class A is 255.x.x.x. So here x indicates that it's hexadecimal number, that is nothing but 1 octet. Therefore, class A has a total of 2 to the power of 7 minus 2 is equivalent 126 network IDs. Here 2 addresses subtracted because 000 and 127 are special addresses. So here 2 to the power of 24 minus 2 is equivalent to 16777 to 14 host IDs, and IP address belong to class A ranges from 1.x.x.x to 126.x.x.x. So this is class A IP4 addresses where the first bit is set to 0 like this, and encompasses a range of 0.0.0.0 to 127.255.255.255. This class is for large networks and has 8 bits for network and 24 bits for hosts. So here 24 bits for host and 7 bits for network, and first bit for identifying the class A address. So here also we can see class A address is example 77.171.51.13. If we convert into binary number, 77 can be converted like this. So in this, the first bit is class A identifier, and remaining these numbers are used to identify host address, network address. These 7 bits are 1001101. These 7 bits are used to identify network address, and remaining all 24 bits, they are 8 bits, and here 8 bits and here 8 bits, all are used to identify host address. So in this 77 is to identify the network address, 171.51.13 are used to identify the host address. So this is about class A, and we see the class B addressing. The IPv version addressing belong to class B are assigned to the networks that ranges from medium sized to large sized networks. So class B is used for generally medium sized network. The network ID is 16 bits long and host ID is 16 bits long in this class B addressing scheme. An IPv version address, IPv version 4 address which belongs to class B as the first 2 bits in the first octet set to 10. So we are saying about only first octet, nothing but 10. Here we can see, and here also we can see 10. This is nothing but this. As there is 10 in the first 2 bits. This belongs to class B addressing. The higher order bits of the first octet of IPv4 addresses of class B are always set to 10, nothing but 10. The remaining 14 bits are used to determine network ID. The 16 bits of the host ID is used to determine the host in the network. The default subnet mask for class B is 255.255.x.x. Class B has a total of 2 to the power of 14 is equivalent to 16,384 network addresses, and 2 to the power of 16 minus 2 is equivalent to 65,534 host addresses. IPv version 4 address belonging to class B ranges from 128.0.x.x to 191.255.x.x. So here class B network use a default subnet mask of 255.255.0.0 and have 128 to 191 as their first octet. The address 172.16.52.63 is a class B address. In the first octet is 7172, which is between 128 and 191 inclusive. So this 10 indicates that it is a class B address. 14 bits are used to identify network of the network address, and 16 bits are used to identify the host address. So here in this example, class B address 131.171.51.13, and in this, if we convert the entire numbers into binary numbers, the first 2 bits 10 used to identify class B identifier, and remaining 14 bits from this 0 to this 1, this identify the 14 bits are used to identify network address, whereas these 16 bits, the 8 bits and 8 bits, these total 16 bits are used to identify host address. So this is class B addressing scheme. And class C addressing scheme, IPv version address belong to version 4 address belong to class C are assigned to small size networks. Here in this, the network ID is 24 bits long and the host ID is 8 bits long. The first octet of class C IPv version 4 address as its first 3 bits are set to 110. That is nothing but here we can see the first 3 bits 110 indicates that it is class C addressing. Here also we can see class C addressing indicates 110. The higher order bits of the first octet of IP version 4 addresses of class C are always set to 110. The remaining 21 bits are used to determine a network ID. The 8 bits of host ID is used to determine the host in any network. The default subnet mask for class C is 255.255.255.x. The class C as total of 2 to the power of 21 is equivalent to 20 97152 network addresses, and 2 to the power of 8 minus 2 is equal to 254 host addresses. IPv4 address belongs to class C, ranges from 192.0.0.x to 223.255.255.x. So class C networks use a default subnet mask of 255.255.255.0 and have 192.223 as their first octet. The address 192.168.123.132 is a class C address. And the first octet is 192, which is between 192 and 223 inclusive. So here we can see the first 3 numbers in the first octet 110 indicates that it is a class C address, and remaining 21 bits indicates a network ID, and last 8 bits are used to identify the host address in the class C addressing scheme. Here, if we take an example 205.171.51.13, we convert the binary number. After converting this, the first 3 numbers 110 indicates that is the class identifier. This is class C, and remaining 21 bits from this number to and this number. Here we have 5 numbers, 5 and 8 numbers, 8 bits, 13 plus again 8 bits. Total 21 bits are used to identify network address, and remaining 8 bits, last 8 bits are used to identify only host address. So this is about class C addressing scheme in the IPv version 4 addressing. Analysis of class C. Here we can see in this the first 3 bits in the octet 110 are used to identify it's a class C address, and remaining 21 bits from this bit to this bit are used to identify the network ID. So bit 8 to 6 is always 110, this one, and 2 to the power of 21 is this much number of networks, and last 8 bits are used to identify host ID. The 2 to the power of 8 is equal to 56 hosts. So class C networks is 21 bits for the network ID and 8 bits for host ID. And this is why the class C networks have large number of networks, but with only 256 hosts per network. And here also we can see, so this is in this case 192.168.0 is host ID, network ID, and this one 2 is host ID. Class D addressing in IP version 4 addressing. IP version 4 address belong to class D are reserved for multicasting. The higher order bits of the first octet IP version 4 addresses belong to class D are always set to 110. The remaining bits are for the address that interested hosts recognize. Class D does not possess any subnet mask. So class D generally does not have any subnet mask. IP version 4 address belonging to the class D ranges from 224.0.0.0 to 239.255.255.255. So here the very first 4 bits of the first octet in the class D IPv4 are set to 1110. This 1110 indicates that is the class D addressing. Here also 11110 used to identify class D addressing. The class D as a IP version addressing range from 224.0.0.02 to 39.255.255.255. Class D is reserved for multicasting. In multicasting, data is not destined for a particular host. As it is called multicasting, that's why there is no need to extract host address from the IP IPv4 address, and class D does not have any subnet mask. So in this, out of 32 bits, first 4 bits 1110 indicates that it is a class D addressing, and remaining 24 bits are used to identify host in multicasting. IPv4 addressing belong to class E. Now is the class C. Yes, class E addressing, and the class E are reserved for experimental and research purposes. IPv4 addresses of class E ranges from 240.0.0 to 255.255.255.254. This class does not have any subnet mask. The higher bits of the first octet of class E are always set to 4 ones 1111. The IPv4 class is reserved for experimental purpose, mainly for R&D, research and development, or study purpose. The addresses in this class range from 240.0.0.0 to 255.255.254. Like class D, this class 2 is not equipped with any subnet mask. Here in first 4 bits 1111 are used to identify that is class E address, and remaining 25 bits are used for host addressing. So we can identify network ID and host ID of the class A, B, C, D, E by seeing the first. If the first 0 is there, that's why it is a class A, and first 10 is there, this is class B addressing, and in this 110 is there, this is class C addressing, and 11110 is there, it's a class D addressing, and 3 4 ones are there, is a class C addressing. And this is reserved for experimental purpose, and this is reserved for multicasting purpose. So in this, first 8 bits are used to identify network, and remaining 24 bits are used to identify host ID, and here 16 bits are used to identify network ID, and remaining 16 bits are used to identify class B host ID. In the class C, first 24 bits are used to identify network, and the last 8 bits are used to identify host. So like this, at a glance we can see, we can identify each and every class by seeing the first octet. So far we have seen what is IPv version 4 addressing scheme. So now we are going to see IPv version 6, next version. What is the need of IPv version 6, and what are the description, what is the description about IPv6 we will see. The primary function of IPv6 is to allow for more unique TCP IP addresses identifiers to be created. Now that's we run out of the 4.3 billion created with IPv version 4. This is one of the main reasons why IPv6 is such an important innovation for the Internet of Things. So here IPv version is a 32-bit address, whereas IPv6 is 128-bit addressing scheme. Because this is somewhat IPv version 4 is somewhat old one, and by using IPv version 32-bit addressing scheme, we may not be allocate adequate IP addresses to all the devices which are growing rapidly in the present internet era, because there are more number of devices are being connected in the internet, like laptops, desktop computers, mobile phones, and all the networking devices are used to connect in the internet. So that's why, so that 32-bit addressing IPv version 4 is not sufficient to allocate required IP addresses. So that's why with the help of IPv version 6, because IPv version 6 is allowing 128-bit addressing scheme. So we cannot imagine such huge number of IP addresses are available with the IPv version 6. Just what is the need for IPv6? Just as telephones use a system of telephone numbers in order to communicate with each other, every internet connected computing device gets a unique number known as IP address, and that connects it to the global network. So if any devices wanted to be in the network, that must be identified with a unique number, just like in telephone system. So that identification of unique number is a system. So generally we are using IPv version 4 to identify, and the IPv6 is the advanced one to identify that each and every device which is connected to the network. The problem is that the present internet addressing system, the IPv4, has capacity for about 4.2 billion addresses only. So beyond this 4.2 billion addresses, the IPv version 4 is unable to allocate addresses the devices beyond these 4.2 billion addresses. These addresses are not enough for the increasing number of new devices like computers, smartphones, TVs, smartwatches, cars, and so on. So nowadays, every electronic device, electronic gadgets are coming with the facility of networking. So that's why all the as computers are allowing the old computers, generally old personal computers did not have any networking facility. But now all the desktop computers, all the laptops, and all the smartphones, now the present TVs, advanced TVs, televisions, and smartwatches, and also cars are having networking facility. So if these all the devices are connected in the networking, they must be identified with identified with the IP address scheme. So increasing number of these all the devices, the present IPv version 4 with 4.2 billion addresses unable to allocate the addresses to all the devices. So already more than 4.1 billion computing online devices are using IP addresses, and that's why very soon there will be shortage of IPv4 addresses. So here we see the IP version 4, 4.2 billion IP addresses, whereas using IPv version 6, 340 trillion IP addresses are available. So such a huge number by using, because the IP version use 128 bits to identify each and every device in the network, whereas this IP version 4 uses 32-bit addressing scheme to identify each and every device in the network. So IPv4 is of 32 bits. So it can provide 2 to the power of 32 IP addresses. That is nothing but 2 to the power of 32 is equivalent 4.2 billion addresses. To overcome this limitation, so there is a limitation with the IPv version 4, because we can accommodate only 4.2 billion addresses globally with the help of IPv4. So this is not sufficient in the present scenario, because there is rapid number of devices are entering into the network, so that each and every device must be identified with the address. To overcome this limitation, IPv6, what is the limitation? 4.2 billion is the limitation. So already exhausted this limitation. So new addressing scheme or a new numbering system must be provided to identify each and every device which is going to be connected in the network in future. So this is the limitation. So to overcome this limited, IPv6 address introduced. See what is the capacity of IPv version 6 addressing scheme. So IPv6 is of 128 bits length. It is 4 times of the IPv version in its bit size. So 2 to the power 128 is equivalent, we get this large number. The total IP address is equivalent to 340 trillion. Such a huge number of IP addresses are available with IPv version 6 addressing scheme. So IPv6 is short for Internet Protocol version 6. So far we have seen IPv version 4. The IPv6 is a network protocol, also referred as IPing. IPing means Internet Protocol Next Generation. So generally IPv6 referred as IPing, it is called Internet Protocol Next Generation. For Internet and Ethernet network transmission, first it introduced in the year 1996. IPv6 includes improvements over IPv4 such as wider range of internet addresses, improved routing and auto configuration, amended encryption, and more. Not all operating system application can utilize IPv6. However, new software is slowly making the transition to IPv6. On June 6, 2012, Google and several thousand other companies migrated to IPv6. Since then, more companies have updated their services and product as well to the IPv6. Internet Protocol version IPv6 is a network layer protocol that enables data communication over a packet switching network. Packet switching involves the sending and receiving of data in packets between two nodes in a network. So generally over the internet packets are sent. It means the original data is being converted into packets, nothing but divided into packets, and these packets are transmitted over the network, and at the receiving end all the packets are received and they are reorganized to get the original data. The working standard for IPv6 protocol was published by the Internet Engineering Task Force (IETF) in 1998. The IETF specification for IPv6 is RFC 2460 The IPv6 intended to replace the widely used Internet Protocol version 4 that is considered the backbone of the modern Internet. IPv6 is also referred to as the next generation Internet because of its expanded capabilities and its growth through recent large-scale deployments. The explosive growth in mobile devices, including mobile phones, notebook computers, and wireless handheld devices, has created a need for additional blocks of IP addresses. This is the most important factor for developing IP address version 6 because there is a maximum growth, a rapid growth in mobile devices, including mobile phones, notebook and laptop computers, and wireless handheld devices, has created need for additional blocks of addresses. Because when IPv version 4 was created, there were only maximum desktop computers or some of the notebook computers used to connect in the network, so that the IPv version 32-bit addressing scheme was very much enough to allocate all IP addresses to them. Whereas now the rapid growth is there, all the mobile devices, wireless also devices also included in the network, and that's why the additional blocks of IP addresses are needed. So IPv version currently supports a maximum approximately 4.3 billion unique IP addresses, whereas IPv6 supports theoretical maximum 2128 addresses. There is nothing but, to be exact, this is a large number figure, nothing but 340 trillion. Recent advancements in network technology, including network address translation, have temporarily lessened the urgency for new IP addresses. However, recent estimates indicate that IPv version 4 addresses could be exacted as soon as 2012. IPv6 and IPv4 share similar architecture. The majority of transport layer protocol that function with IPv version 4 will also function with the IPv version protocol 6 version protocol. Most application layer protocols are expected to be interoperable with IPv6 as well, with that notable exception of file transfer protocol. FTP uses embedded network layer addresses to facilitate data transmission. An IPv6 address consists of 8 groups of 4 hexadecimal digits. If a group consists of 4 zeros, the notation can be shortened using colon to replace the zeros. The main advantage of IPv6 is increased address space when we compare with the IPv4. The 128-bit length of IPv6 address is significant gain over the 32-bit length of IPv addresses, allowing for an almost limitless number of unique IP addresses. The size of the IPv6 address space makes it less vulnerable to malicious activities such as IP scanning. IPv6 packets can support larger payload than IPv4 packets, resulting in increased throughput and transport efficiency. IPv6 was developed by Internet Engineering Task Force to deal with the problem of IPv4 exhaustion. IPv6 is 128 bits address having an address space of 2 to the power 128, which is way bigger than IPv4. In IPv6, we use colon XR representation, whereas in IPv4 we use data decimal notation, but in IPv6 we use colon XR representation. This is the main difference between IPv version 4 and 6. IPv version use 32-bit data decimal notation, whereas IPv6 uses colon XR representation. There are 8 groups and each group represents 2 bytes. So like this, there are 16 bytes. So there are 8 groups: 1, 2, 3, 4, 5, 6, 7, 8. So these are represented with the help of colons. 1, 2, 3, 4, 5, 6, 7, 8 colons are there, and this is called colon hexadecimal representation. So IP address 6 version 6 is represented in the form of colon hexadecimal representation, whereas IPv version 4 representation is 32-bit data decimal notation. IPv6 is colon hexadecimal notation. This is called colon hexadecimal notation. That is of 16-byte length. That is nothing but 128 bits in total. An IPv6 address is made up of 128 bits divided into 8 16-bit blocks. So here we can say 8 16-bit blocks. This is a 16-bit block, because each and every character digit represent hexadecimal number. So there are 16 bits are there. So 16 bits into 16 bits are there. Each block is then converted into 4-digit hexadecimal, like this, 4-digit hexadecimal. This is 4-digit hexadecimal, and there are 8 4-digit hexadecimal numbers separated by colon. These 4-digit hexadecimal numbers are separated by colon. That's why this representation is colon hexadecimal representation. Example given below is 128-bit IP address represented in binary format and divided into 8 16-bit blocks. So there are 8 16-bit blocks. This is one hexadecimal binary number, 16-bit binary numbers, and 2 and 3 and 4, 5, 6, 7 and 8. 8 16-bit blocks are there in total. A 128-bit, this is a 128-bit number to represent IP address. So each block is then converted into hexadecimal and separated by colon. So this number is equivalent to 2001, and this number is equivalent to 00040, and this one is equivalent to 3238, and this number is D, F, E and 1, and this number is 0063, and remaining these are zeros and zeros, zeros and zeros, and this is equivalent to FE, FB. This binary is equivalent to hexadecimal separated by colon. So an IPv version address is 128 bits in length and consists of 8 16-bit fields, with each field bounded by a colon. Each field must contain hexadecimal number, in contrast to the dotted decimal notation of IPv4 addresses. So in IPv4 that is called dotted decimal notation. This is in this IPv6 it is called colon hexadecimal notation. So in the figure the X represent hexadecimal numbers. So in this example, basic IPv6 format, address format, this is a prefix. First 3 16 bits are used to identify prefix, and remaining 16 bit is used to identify subnet ID, and here 4 16 bits are used to interface ID, and remaining 16 bits are used to in this site prefix here, and subnet ID here, and also interface ID. So here also you can see among 8 16 bits 1 2 3 4 5 6 7 8, the first 3 16-bit numbers, nothing but 48 bits are used for prefix, and here 16 bits are used to identify subnet, and remaining 4 16-bit, nothing but 64 bits are used for interface ID. So this is one of the example. These are the hexadecimal, 3 hexadecimal numbers. These are 4 hexadecimal numbers, nothing but 16 bits, 3 into 16 bits, 48 bits site prefix, and 16 bits are used for subnet ID, and 64 bits are used for interface ID. So here in this number 2001 colon 0db 8 3c 4d and 005 and 4 zeros 1a2f and 1a2b. These examples show all 120 bits of IP address. The first 48 bits, these 48 bits, and 2001 and 08db and 3c 4d contain the site prefix representing the public topology. The next 16 bits, nothing but 00015, contains the subnet ID representing the private topology for the site. The lower order bits write more 64 bits. These 64 bits contain the interface ID. This is IPv address structure. The leftmost 3 fields, nothing but 48 bits, contain the site prefix And the prefix describes a public topology that is usually allocated to or site by an ISP, nothing but internet service provider or regional internet registry authority. The next field is the 16-bit subnet ID, which another allocate to your site. The subnet ID describes the private topology, also known as site topology, because it is internal to the site. The rightmost four fields, nothing but 64 bits, contain the interface ID, also referred to as a token. The interface ID is either automatically configured from the interface's MAC address, mid access control address, or manually configured in EUI64 format. So like this we can see an IPv6 address in hexadecimal format. This is 128-bit address, and here we are converting it to binary, and then here these zeros can be omitted. There are rules in IP address 6. Even after converting into hexadecimal format, IPv6 address remains long because it is 128-bit addressing scheme. So IPv6 provides some rules to shorten the addresses. What are the rules here? The rule 1, discard leading zeros, where we have to discard. So this is one of the IP address version 6, which is having 32 bits, nothing but in the type of 8 into 4 hexadecimal numbers. So in the block 5, this one, block 5 0063, the leading two zeros, these zeros can be omitted, such as in the fifth block, like that we can write. So 001, 2001 as it is we have written, and 4 zeros as it is we have written, 3238 is okay, DFE1 is also okay, but here we have written only 63 instead of 0063, because these 00s can be omitted. These are leading zeros. We are discarding these two zeros, writing only 63. This is understood that before 63 there are 00, and remaining all we have written same thing, 00 and 00s, FE. So rule 1 is discarding the leading zeros in any number. Rule 2, if two of more blocks contain consecutive zeros, omit them all and replace with double colon sign, such as 6th and 7th block. So in this 6th and 7th block all are zeros, and also that too in consecutive. Two blocks are in consecutive, and also they are containing zeros. That's why we can omit these zeros, two blocks. Instead of these two blocks, we may have two colons continuously. So in the previous example, as per rule 1, there were the leading zeros in this block. We have omitted these leading zeros. Straight away we are writing 63, omitting 0 zeros. And here also we are discarding these entire zeros, because as per rule 2, these are consecutive numbers contain 0 zeros. That's why instead of these two 0 zeros, we are indicating two colons. So consecutive blocks of zeros can be replaced only once by double colons. So if there are still blocks of zeros in the address, they can be shrunk down to a single zero, such as second block, this one. So second block is 0. So we are shrinking to only single zero. So we are discarding leading zeros in this block. We are replacing this leading consecutive all zeros by separate colons. Still there are zeros. That's why instead of these 4 zeros, we are indicating only 0. That is nothing but using the address as per rule 1 and rule 2 of the IP address rules, IPv6 version address rules. What are the types of IP address 6 version? There are unicast address, multicast addresses, and anycast addresses. Unicast addresses identifies a unique node on a network and usually refers to a single sender or a single receiver. Multicast addresses, it represents a group of IP devices, can only be used as the destination of the datagram. Anycast address, it is assigned to a set of interfaces that typically belong to different nodes. So there are types of addresses: unicast, multicast, and anycast address. So if we compare IPv4 and IPv6 addresses, the maximum value of a 32-bit number is 2 to the power of 32, or 4.3 billion. So the maximum number of IPv version 4, which is called the address space, is about 4.3 billions. In the year 1980s, this was sufficient to address every networked device, but scientists knew that this space would quickly become exhausted. Technologies like network address translation have delayed the problem by allowing many devices to use a single IP address, but a larger address space is needed to serve the modern internet. The major advantage of IPv6 is that it uses 128 bits of data to store an address, permitting 2 to the power of 128 unique addresses or 340 duodecilene. This is a huge number. This is a huge number. That is nothing but 2 to the power of 128. The size of IP address 6 version address space is 340 duodecilene, is much larger than IPv version 4. So what are the benefits? If you see the IPv6 benefits, IPv6 supports source and destination address that are 128 bits, nothing but 16 bytes long. Uses a link local scope all nodes multicast address, and IPv6 does not require manual configuration of DSCP, whereas we are doing in IP version 4 DSCP, dynamic host configuration protocol. Uses host address AAA source resource records and DNS to map host names to IP version 6 addresses. Uses pointer resource records in IPv6, ARPA DNS domain in map IPv6 address to host names, and IPv6 supports a 128 byte packet size, 1280 byte packet size without fragmentation. And IPv6 uses flow label failed to identify packet flow for quality of service handling by router. Uses Internet Control Message Protocol version 6, ICMP version 6 router solicitation and router advertisement message to determine the IP address of the best default gateway. Uses IPv6 uses multicast neighbor solicitation message to resolve IP addresses to link layer addresses. And IPv6 version uses multicast listener discovery messages to manage membership in local subnet. So here we have three benefits: enhanced security, optimization of protocol, end-to-end connectivity, as well as traceability. So in the enhanced security, extra layer of security added into the protocol in IPv6 packet header consists of encapsulated security payload, that is nothing but ESP means encryption of packets, and authentication header means authentication of the sender of the packets. These two parameters take care of privacy and security of packets transmitted over the network. This is enhanced security in IP version 6. Optimization of protocol means some disadvantages of IPv4 are removed from IPv6, like unnecessary fragmentation and headers. IPv6 made up of best things from IPv4 and excluding minor flaws of IPv versions 4. Here, end-to-end connectivity. Many organizations implement network address translation, which is used in IPv version 4 networks, that allows several computers to connect to a public network using the same public IP version 4 address. Because of network address translation NAT, we are not able to trace packet end to end. If we are using IPv6, then there is no need of NAT, and a packet can be traced from ultimate source to ultimate destination. This is the facility. These are the three facilities and then the benefits in using IPv6: enhanced security, optimization of protocol, end-to-end connectivity, as well as traceability. So IPv6 features are there. Large address space. In contrast to IPv4, IPv6 uses 4 times more bits to address a device on the internet. This much extra bits can provide approximately 3.4 into 10 to the power of 38 different combinations of addresses. These addresses can accumulate the aggressive requirement of address allotment for almost everything in this world. According to an estimate, 1564 addresses can be allocated to every square meter of this earth by using one IPv6 version. Simplified header. IPv6 header have been simplified by moving all unnecessary information and portions which are present in IPv6 header to the end of the IPv6 header. IPv6 header is only twice as bigger than IPv4, providing the fact that IPv6 address is 4 times longer. Here, end-to-end connectivity, every system now has a unique IP address and can traverse through the internet without using NAT or other translating components. After IPv6 is fully implemented, every host can directly reach other hosts on the internet with some limitations involved like firewall, organizations policies, and etc. So there is effective end-to-end connectivity in IPv version 6. And auto configuration, IPv6 supports both stateful and stateless auto configuration modes of its best host devices. This is why absence of DHCP server does not put halt on the inter-segment communication. Faster forwarding and routing, simplified header puts all unnecessary information at the end of the header. All information in the first part of the header are adequate for a router to take a routing decision, thus making a routing decision as quickly as looking at the mandatory header. IP security, initially it was decided for IPv6 to must have IPsec security, making it more secure than IPv version 4. This feature is now been made optional. So no broadcast. Though Ethernet or token ring are considered as broadcast network because they support broadcasting, IPv6 does not have any broadcast supports anymore left with it. It uses multicast to communicate with multiple hosts. So another IPv6 features, Anycast support. This is another characteristic of IPv6. IPv6 has introduced Anycast mode of packet routing. In this mode, multiple interfaces over the internet are assigned same Anycast IP address. Routers, while routing, sends a packet to the nearest destination. So another feature is mobility. IPv6 designed keeping mobility feature in mind. This feature enables hosts such as mobile phones or laptops or cars or any networking devices, mobile networking device to roam around in different geographical area and remain connected with the same IP address. IPv6 mobility feature takes advantage of auto IP configuration and extension headers. This facility is very less or not available in the IPv6 version. IPv4 version. Enhanced priority support. Where IPv4 used 66 bits DSCP, nothing differential service code point, and 2 bits ECNX bits congestion notification to provide quality of service, but it could only be used if the end-to-end service supports it. That is, the source and destination device and underlying network must support it. Whereas in IPv6, traffic class and flow level are used to tell underlying routers how to efficiently process the packet and route it. So another feature, smooth transition and extensibility. Large IP address scheme in IPv6 enables to allocate services allocate devices with globally unique IP addresses. This assures that mechanism to save IP address such as NAT is not required. So the devices can send or receive data between each other. For example, voice over IP or any streaming media can be used much efficiently. Other fact is that a header is less loaded to routers can make forwarding decision and forward them as quickly as they arrive. Extensibility, one of the major advantages of IPv6 header is that it is extensible to add more information in the option part. IPv4 provides only 40 bytes of options, whereas options in IPv6 can be as much as the size of IPv6 packet itself. So these are the features of IPv6. So far in this class we have seen what is IPv4, what it contains, classes of IPv4 version. So IPv4 version is 32-bit addressing scheme, and IPv6 version is 128-bit addressing scheme. We have seen what is the need for IPv6 version, because by using IP version 4 we can accommodate only as it is a 32-bit addressing scheme, we can accommodate only 4.3 billion addresses. You can uniquely identify any device with this 4.3 billion only. Beyond this figure, we cannot use IP version. So that's why IPv6 is introduced. By using IPv6 version addressing scheme, we can have IPv6 version is 128-bit addressing scheme. So we can have 2 to the power of 128 is equivalent to 340 trillion numbers of IP addresses, unique IP address can be allocated to all the devices which are connected to the network. So this is all about IPv4 and IPv6 versions addressing scheme. Thank you.